Yeah, she's here. Okay, then let's get started. Welcome back to this class. So, we just started off with solving linear inequalities in one variable. Okay, so we have seen the simplest cases so far. We have seen very simple cases like, say, if somebody is telling you, say, for example, if somebody tells you x greater than 3. If somebody tells you x greater than 3, that is a very simple linear inequality. Of course, what is the solution? Solution can be represented on a number line. So you draw a number line. Okay. So we have 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. And the solution will be all numbers from 3. And it keeps going to the right of the number line, to the right of x is equal to 3. Right? So I've carefully put a circle at x is equal to 3 to indicate that 3 is not included. Okay. So this is a very simple case. This is a very simple case of a linear inequality in one variable. Right? So you're able to recognize similar inequalities, right? For example, if you have x less than or equal to minus 3. If you have x less than or equal to minus 3, how can we represent it on the number line? You take the number line, you have minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, minus 4, minus 5, okay, minus 6. And if it says x less than or equal to minus 3, what does it mean? All numbers less than minus 3. Okay, on the number line, all numbers to the left side of minus 3 will form the solution set. Okay, so in this case, minus 3 is included. So you just put a dot to indicate that minus 3 is also included in the solution. Minus 3 is also included in the solution. Cool. So this idea is clear, right? Please let me know. Yeah. So of course, the problem is all linear inequalities won't be this simple. Okay, all linear inequalities will not be this simple. So we'll have complicated linear inequalities. Say for example, 2x plus 5 is less than or equal to 4x plus 7. These kind of linear inequalities will come. So we'll see how we can solve these linear inequalities. So this idea is very clear, right? I mean, if you have a very simple inequality, how do I represent it on the number line? How does the solution set look like? Okay, if you have learned about sets, have you learned about sets? Yes or no? Set. Yeah. Others, have you heard of the term called set? Yeah. In terms of set builder form, this can be represented as set of all x such that x is greater than 3. Set of all x such that x greater than 3. So what does that mean? It simply means that you have a set which consists of numbers, and the numbers are chosen in such a way that they are greater than 3. Okay. What does that mean? It consists of a set of numbers, a collection of numbers. This collection of numbers will be such that they are all greater than 3. That's all. So one thing I want to reiterate is any number greater than 3 not only just include what the integers, they can be any rational number or irrational number. For example, 3.5 a solution to this inequality? Is 3.5 x is equal to 3.5? Is this a solution? X is equal to 3.5. Is this a solution? X is equal to 3.5. Is this a solution? Yes, indeed. Okay. 3.5 is going to be a solution because 3.5 lies on the right side of 3 on the number line. So don't be under the impression that only integers will form the solution set. It is not the case. You can have any rational number, any irrational number as a part of the solution set. Yes. So 3.5 is the solution because 3.5 will lie somewhere here. 3.5 is going to be somewhere here. On the number line, 3.5 will lie between 3 and 4. Okay. Yes. This is clear, right? Is this confusing? Is this confusing? Prisha and Robin? Yeah. Okay. Now let's see some more complicated linear inequality. So of course, if instead of inequality, if we had an equality sign, what will you do? Instead of inequality, if you had an equality sign, what will you do? Our fundamental idea is to isolate the variable. So our fundamental idea is to isolate the variable. Okay. Say for example, if we have a very simple case of x plus 9 less than or equal to 12. How do we isolate the variable? By isolating variable, what do we mean? We mean that only variable is present on one side of the inequality. Okay, the only variable is present as itself. There's nothing added to it. There's nothing multiplied to it. Okay, so you have to isolate the variable. So for isolating variable, you have to see what operations are applied on the variable, and you have to keep undoing it to remove that, to get rid of this 9. Get rid of this 9. Get rid of this 9. So there is a 9 added to that number. So you have to undo that operation. For undoing that operations, what do we have to do? You have to add a negative 9 or you have to subtract a 9 on both sides. So just like in inequality, just like in an equation, just like in an equation, we can add the same constant number on both sides of the inequality. Just like in an equation, we can add or subtract the same constant on both sides of the inequality without doing any damage to the inequality. Say, for example, 3 is less than 7. 3 is less than 7. So if I add 2 on both sides of the inequality, if I add 3 on both sides of the inequality, this becomes 7 is less than 9. Okay, the inequality is still true. Nothing happened to the inequality. The inequality is still true, right? So idea is very simple. Just like in an equation, you can add the same numbers or you can subtract same numbers on both sides of the inequality. So can you tell me what will be the solution of this inequality? What will be the solution of this inequality? Can you please tell me what will be the solution to this inequality? X plus 9 less than or equal to 12. What will be the solution to this inequality? Please work out and let me know. Yeah, others, please let me know. Please also try to represent it on the number line. Please represent it on the number line. Please represent it on the number line as well. Okay. Just draw a number line and represent it on the number line so that you have some better picture. Yeah. Robin, do you have the answer? What do? We just add -9 on both sides, right? So we have this 9 is gone. We have x less than or equal to 3. On the number line, this can be represented as say 0, 1, 2, 3, 4, 5, -1, -2, -3, -4. Less than or equal to 3. So 3 and all numbers to the left of 3 are included here. Got it? That's very simple. Yeah. So when you have our ultimate idea is to isolate the variable. For isolating variable, just like in an equality, just like in an equation, you can keep adding same numbers on both sides, keep subtracting same numbers on both sides without affecting the inequality. So our idea is to basically undo the operations one by one, which are applied on the variable, so that the variable will be isolated. Yeah. So let's see another example. We have 3x less than or equal to 6. So in this case, listen carefully. In this case, is the variable isolated? No. X is being multiplied by a 3. So we have to get rid of this 3. To get rid of this 3, you have to divide by 3 on both sides. Okay. Just like in an equation, you can divide both sides of the equality with the same positive number. When it is a negative number, there's a difference. I'll come to that. When it is a positive number, you can divide the inequality with the same positive number on both sides without affecting the inequality sign. For example, we know 4 is less than or equal to 8. This is a true statement. 4 is less than or equal to 8 is a true statement. Now, if I divide it by 2 on both sides, you still have a true statement. 2 is less than or equal to 4. 2 is less than or equal to 4. Okay. So here the solution will be, you divide the entire expression with 3 on both sides. Okay. Now your solution will be x less than or equal to 2. X less than or equal to 2. This is clear? Clear? Just like adding or subtracting on both sides, you can do a division on both sides. Got it? You may yes, if this is clear. But when you're dividing or multiplying with a negative number, there's a small difference. Okay, there's a small difference. Let's see what happens. Let's see what happens to an inequality when you are multiplying or dividing with a negative number. Let's see, we have 4 is less than 8. 4 is less than 8. Now, what happens when I multiply this inequality with some negative number? Say, for example, I multiply by negative 1. So the numbers on the number on the left side becomes -4. The number on right side becomes -8. Now, is the inequality still valid? Is the inequality still valid? Is the inequality still valid now? Is -4 less than -8? Is -4 less than -8? Is -4 less than -8? No. What happened now? What happened now? The inequality sign just reversed. Okay. The inequality sign just got reversed. Okay. Have you seen this in school? Have you realized this fact from school? That if you multiply an inequality with a negative number, the inequality will reverse its sign. The inequality will reverse its sign. Have you seen this in school? Yes. Okay. So a number line, let's see how this can be understood. Please listen carefully. So I have 0 here. 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3, -4, -5, -6, -7, -8. Initially, our 4 was here and our 8 was here. So 4 is to the left side of 8. So we can easily say that 4 is less than 8. 4 is to the left side of 8. So we say that 4 is less than 8. But when you multiply it with -1, the numbers become -4 and -8. So -4 and -8 will be, -4 is here, -8 is here. So 4 jumps to this place, 8 jumps to this place. Now what happens? What happened now? What happened now? Now your -8 is on the left side of -4. -8 is on the left side of -4. Okay. So we have -4 greater than -8. Hope this is clear. Yes. Tell me. Yeah, okay. So the summary is this. To solve a linear inequality in one variable, you follow the same approach you used for linear equations. Okay. Basic idea is to isolate the variable. For isolating variable, you have to do like what? If there are brackets, you have to expand the brackets. If there are like terms, you can combine the like terms. And ultimately, look at the operations that are being applied on the variable. Now you have to keep undoing these operations one by one to isolate the number. Okay. To undo a addition, you have to subtract the same number. Okay. Same number can be added or subtracted to an inequality without affecting the sign of the inequality. But when you're dividing or multiplying, with a negative number, you should be careful. With a positive number, that is absolutely fine. When you're multiplying or dividing with a positive number, it's absolutely fine. But when you're multiplying or dividing with a negative number, you should be very careful because the inequality will reverse its sign. So that is a summary. Okay. Now shall we move on to the problems? Shall we move on to the problem sheet? Yeah. Let's see the problems one by one. So question number 1. X minus 3 is greater than -6. x minus 3 is greater than minus 6. So on the LHS, there is the variable, but the variable is being added with a number which is minus 3. So you have to undo that operation. So you add 3 on both sides, add 3 on both sides. So we have x minus 3 plus 3. The inequality will remain the same, minus 6 plus 3. So x is greater than minus 3. X is greater than minus 3. X is greater than minus 3. Have you tried this question at home? Have you got the answer? Have you got the answer? Yeah. Okay. So minus 3 is the answer. Again, next question. The solution of the inequality 0.7 greater than or equal to x minus 0.4. Okay. So what do? We add 0.4 on both sides of the inequality. So we have 0.7 plus 0.4 greater than or equal to x minus 0.4 plus 0.4. So this will go away because these will get cancelled off. You're left with 1.1 greater than or equal to x. 1.1 greater than or equal to x. So that is as good as writing x is less than or equal to 1.1. X is less than or equal to 1.1. So x is less than or equal to 1.1. So this is our answer. Yes, please give me a yes. This is okay. Now let's move on to the next question. Okay, here they have not asked us a solution set. The question says which of the following is a solution to the inequality 4.7367 plus z less than 20.1784. So let's see this. We have question number 3. 4.7367 plus z is less than 20.1784. So we have z less than 20.1784 minus 4.7367. So you have to do this decimal operations. Of course, if it is a calculator section, if this question appears in the calculator section, it is better to pick up the calculator so that you don't make a mistake. Okay, it is better to pick up the calculator. If it is in the calculator section, it is better to pick up the calculator and do it. Okay, otherwise you have to do your regular arithmetic. So we have 20.1784 minus 4.7367. So we have 7. So that is 7 here, that is 1. And you have a 4 here. And then you have a 4 here. And this is 15. 15.4417. 15.4417. So we have z less than 15.4417. This is clear. If you have a calculator, it is better to pick up. Of course, if this question falls in the calculator section, most probably this question will fall under calculator section. But even if it appears in a non-calculator section, you should be able to do it. Yes. Now let's try to understand the solution geometrically. I mean, in a graph, number line. On the number line, you have 0 somewhere here, 0 somewhere here. Say you have some 15 here, 15, 16, 17, 18, 19, 20. It says Z is less than 15.4417. 15.4417. So that is some number somewhere here. Okay. So our solution will be in this way. Our solution set will be in this way. Our solution set will be in this way. Our solution set will be in this way. Yes. Now question does not talk about the entire solution set. You have to find the value that falls within the solution set. So there is 15 given, 16 given, 24 given, 25 given. So what is the answer here? We have 15, 16, 24 and 25. Does 16 come in the solution set? Does 16 come in the solution set? No, it doesn't, right? And what about the other numbers, 24 and 25? 24 and 25, do they come in the solution set? No, they don't, right? The only number in the options that fall in the solution set is 15. 15. 15 is the right answer. 15 is the only number that falls within the solution set. Got it? Yes, there is one more way to solve this question. Okay, there is one more way to solve this question, that is by option verification. So I'm talking about option verification. Let's try to verify the options. Take each options and try to verify it. Because the options are some simple whole numbers. It is easy to do the math here. So let's see that. So when I put 15, what happens to the inequality? So if I put Z is equal to 15, our inequality will become 4.7367 plus 15 less than 20.1784. Of course, in the LHS, the second number has no decimal part. The decimal part is 0. Okay, so when you add these two numbers, the decimal part of the first term will be preserved. So this is going to be a 19.7367 less than 20.1784. So this is going to be a true statement. This is a true statement because we have something 19 point something on the LHS and we have 20 point something on the RHS and we are related by the less than sign. So that is a true statement. So of course our A is the right answer. You understand what I did here? You got what I did here? Yes or no? I am just verifying the options. In this question, don't you think this is an easier approach? Don't you think this is an easier approach? This is an easier approach, right? Yes. And the next option, if you take the next option, this is going to be 20.7367 less than 20.1784. So this is a wrong option because we have 20.7367 and 20.1784. Yeah, so that is wrong. Similarly, for the other options, you can verify, right? So this is an easier approach in these questions. Of course, this may not work for all questions, but in this particular question, option verification is a much simpler solution. Yeah, let's see the next question. Ayan has 3 chocolates. Together, Sidra and Ayan have at most 12 chocolates. What does at most? At most. What does that mean? At most. At most indicate the maximum. The maximum. Okay. So if Ayan has 3 chocolates, suppose if Sidra has say X number of chocolates, together how many chocolates do they have? They have X plus 3 chocolates. Okay. They have X plus 3 chocolates. See, this question is very important because we are starting with word problems where you have a real life scenario given that needs to be modeled as a linear inequality. So we have seen this for linear equations. We have seen this for linear equations. So here we are talking about linear inequalities. Okay. So such questions are common in SAT where there will be a real life scenario or maybe a word problem. Instead of a mathematical expression, a question will be given, uh, maybe involving long sentences describing a word problem or a real life situation. Okay. So together they have X plus 3 chocolates. I have assumed that because the unknown quantity is the number of chocolates this Sidra has. Okay, Sidra has X chocolates. Ayan has 3 chocolates. Together they have X plus 3 chocolates. Now you have to look at the term which talks about at most. At most. What does it mean? At most. So the maximum number of chocolates they could have together is 12. The maximum number of chocolates they can have together is 12. So this number X plus 3 has to be less than or equal to, see, this is, when you see a word problem, you should be able to like look at the wordings. You have to catch the significant part. So the significant things are there is a number, there is an unknown variable, and there is a condition that translates to an inequality. Yes. Yes or no? So what does at most mean? At most mean together they have a maximum of 12 chocolates. Together they have a maximum of 12 chocolates. So X plus 3 less than or equal to 12. That is the maximum. 12 is the maximum. So the number they have is going to be less than or equal to 12. The number they have is going to be less than or equal to 12. Got it? Yes or no? I hope you understood this. So when you have a word problem, just look at the numbers and search for the unknown quantities and search for the term that describes the condition. So here they say you have some person has 3 chocolates, another person has unknown number of chocolates. Together, they can have at most 12 chocolates. So they have a maximum of 12 chocolates at the most. At the most, they can have 12 chocolates. So put together, their number will be 12 or less than 12. It cannot be greater than 12. It cannot be greater than 12, so it needs to be less than 12. Now let's look at the next option. Iqbal sold 3 books. To win a prize, Iqbal must sell at least 12 books. So I have already sold 3 books. To get a prize, I must be selling at least 12 books. So at least means what? Minimum. At least 12 books. I should be selling a minimum of 12 books. I should be selling a minimum of 12 books. I should be selling a minimum of 12 books. So I have already sold 3 books. So further, suppose I'm going to sell X more books. I'm going to sell X more books. Okay. I suppose I'm going to sell X more books. Okay. To win a prize, the total number of books that I sell should be at least 12. Should be at least 12. Okay. So in this case, already I have sold 3 books. I'm going to sell a further of X books, and this should be a minimum of 12 books. So it can be 12 or more. It can be 12 or more. At least 12 means what? 12 or more. At least 12 means what? 12 or more. So the total number of books must be greater than or equal to 12. Greater than or equal to 12. I hope this is clear. Hope this is clear. Yeah. Let's see the next option. Ledida has 3 hats. Ledida and her sisters have fewer than 12 hats. Okay. So some person has 3 hats, and including some others put together, they have lesser than 12 hats. So fewer than. So less than 12. So this is 3. Okay. Sisters has say X hats. So put together, they have 3 plus X hats. So this 3 plus X has to be less than 12. 3 plus X is less than 12. 3 plus X is less than 12. Okay. Yes. Okay, now can you tell me what will be? Just read up this option and can you tell me what inequality will be represented by the statement given in option D? What inequality can you represent the statements? What inequality can be used to represent the statement that is given in option D? Can you please tell me? Can you please tell me? Please read up the option. Please read up the option. Just frame that statement into a mathematical statement. Convert the statement into a mathematical expression. That's what I need. Convert the statement into a mathematical expression. Please tell me now. Let me know. Please let me know. See, there is some person who has already swam 3 laps in this week. So he has to further swim. He has to further swim so and so laps. So that put together, he must be swimming more than 12 laps. So what inequality represents this statement? What inequality represents the statements? Others, please let me know. Think. Yeah, the idea is very simple. See, he has already swam 3 laps, so there is 3. And suppose he is swimming x more. So 3 plus x has to be more than 12. 3 plus x has to be more than 12, which is same as x plus 3 is greater than 12. Now look at the 4 options. The first option says x plus 3 is less than or equal to 12. The second option says x plus 3 is greater than or equal to 12. The third option says x plus 3 is less than 12. Fourth option says x plus 3 is greater than 12. So this is a very good question, right? Now tell me which one matches with x plus 3 less than or equal to 12? Which one matches with x plus 3 less than or equal to 12? Which one matches with x plus 3 less than or equal to 12? Which one? Which one? A option, right? A is the answer. A is the right answer. A is the right answer. I think there is a correction in the solution given to you. In the solution given to you, there is a mistake. Okay. Anyway, I'll be updating the problem sheet and then I'll share it at a common place. I'll give you access to that. Okay, I'll keep updating. I'll rectify the mistakes. There could be typing mistakes, things like that. See, I'm not typing it myself, so there could be some mistakes. So I'll rectify these mistakes and I'll give you an updated version and give you access to that. Yes, so this is fine. This question is fine. Let's go to the next question. Which graph represents the solution of y plus 3 less than 1? Y plus 3 less than 1. So you can simply solve it. So we have y less than, so y plus 3 is less than 1. So add minus 3 on both sides. Y plus 3 minus 3 is less than 1 minus 3. So we have y less than minus 2. Y less than minus 2. Now tell me which one represents y less than minus 2. Which one represents y less than minus 2? Which graph represents y less than minus 2? Y less than minus 2, what does it mean? It represents all the numbers on the left side of minus 2, okay, but minus 2 is not included. So what is the answer here? What is the answer here? What is the answer here? A, B, C, D. What is the answer? A is the answer, right? A is the right answer. Just look at the graph. Just look at the graph. We have all the numbers on the left side of minus 2. Minus 2 is not included. Minus 2 is not included. Okay, others. So you just have to tell me. That's all. If it's, I don't know whether why you're not replying. Is it too easy or you're taking time? You're not replying because it's too easy or it's taking time for you. Whatever it is, please let me know, because without some kind of feedback, we can't go forward. Yes. Okay. Next question. Which inequality does not have the same solution as b plus 12 less than or equal to 26? These are all different varieties of problems. Which inequality does not have the same solution as b plus 12 less than or equal to 26? So first of all, let's try to see the solution to this inequality. What is the solution to this inequality? B plus 12 less than or equal to 26. So we have b plus 12 less than or equal to 26. Again, to get the solution to this inequality, you have to get rid of the operations that are applied to the variable. So you see that a 12 is added to b. So you have to subtract 12 on both sides. So we have our solution as b less than or equal to 26 minus 12 is going to be 40. B less than or equal to 14 is the solution. B less than or equal to 14 is the solution. Yeah. Now we have to look at each option. So this is exactly same as this. This is exactly same as this. Now b plus 6 less than or equal to 20. What does it represent? Again, b less than or equal to 40. That is also same. Here, what does it represent? Add 4 on both sides. So we have 14 greater than or equal to b, which is again the same expression. Which is again the same expression, right? It is the same expression once again. Okay. Now in this option, we have b less than or equal to 26, which is different from the others. So option A, option B, option C represent exactly the same thing given in the question. Option A, option B, option C represent exactly the same thing given in the question, but option D represents something else. So question talks about which inequality does not. So you have to mark D as the answer. Our answer will be D. Our answer will be D because the question talks about the inequality which does not have the same solution. Clear? Clear? Others, please. Okay, next question. Which inequality does not have the same solution as minus 2 by 3 times y greater than 4? Okay, here we need to be careful because there is a negative sign. Okay, there is a negative sign and negative number is being multiplied with y, so you need to be careful. Okay, let's see that. Let's see how this can be solved. So we have minus 2 by 3 times y greater than 4. So you understand that your minus 2 by 3 is being multiplied uh, with y on both sides. You understand that? So how do we get rid of that? How do we get rid of the number? 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 You have to divide by the number, right? Okay, we can do that as well. Okay, you can do that in multiple steps, or you can, as Anjali mentioned, you can do that way as well. Okay, so I'll give both methods. So Anjali is telling this is basically minus 2y divided by 3 greater than 4. So multiply both sides by 3. So we have minus 2y greater than 12. Now divide with minus 2 on both sides. Divide on minus 2 on both sides. So we have y. Here it is 12 by minus 2, but inequality will reverse. Inequality will reverse. So we have y less than minus 6. We have y less than minus 6. Yes. So we did this in 2 steps. We could have done this in the first one step itself. How? You see that y is being multiplied with some number. You just divide with that number on both sides. So divide with number on both sides, you get y directly. Okay. So we have y and we have 4 divided by minus 2 by 3. But you need to be careful. The inequality will reverse the sign. Why? What happened here? You are dividing with a negative number. The inequality sign just reverses its sign. The inequality just reverses its sign. Since you are dividing both sides with a negative number. Since you are dividing both sides with a negative number, the inequality reverses its sign. Got it? So when you have a fraction in the denominator, what do? You multiply with the reciprocal. You multiply with the reciprocal. So this is equivalent to 4 times 3 by minus 2, which is 12 by minus 2, which is minus 6. So we have y less than minus 6. Again, we got the same solution. So you can do whatever is comfortable for you. You can do whatever is comfortable to you. You can do it in one step or you can do it in 2 steps. Like you multiply with 3 in the first step, then you divide by minus 2 on the second step. Now please look at the options. Tell me what each option represents. Now look at the options. Look at the options. Tell me what each option represents. You have to find the option that does not match. You need the option that does not match. So can you tell me which one does not match? Just a moment. Yeah, I'm back. Yeah, what does option A represent? Option A. Option A, 12 is less than minus 2y. So you just divide, let's see each option one by one. Option A is 12 is less than minus 2y. So you just divide by minus 2 on both sides, but you should be careful because the inequality will reverse. So we have 12 by minus 2 and y. So inequality just reverse. So minus 6 is greater than y. So again it is y less than minus 6, which is same as the question, which is same as the one given in the question. Right? Cool? This is cool? Yeah. Now next one is B option is minus 3 by 4 times y minus 3 by 4 times y greater than 9 by 2. Minus 3 by 4 times y is greater than 9 by 2. Minus 3 by 4 times y is greater than 9 by 2. Minus 3 by 4 times y is greater than 9 by 2. So what do we do? What do we do here? Okay, you can do this in a single step or you can do it in multiple steps. Okay, so in a single step, to get rid of this minus 3 by 4, you just divide with minus 3 by 4. So y is less than 9 by 2, 9 over 2 divided by minus 3 over 4. So this is going to be 9 by 2 times 4 divided by minus 3. 4 divided by minus 3. Now simplify these expressions, simplify these numbers. So 3, this is going to be 3, 2, this is going to be 2, this is minus 6. Again, you have the same expression y less than minus 6. You have the same expression y less than minus 6. I'll take 2 more minutes. I'll take 2 more minutes. Let's look at option C. Let's look at option C. Option C talks about y by 2 less than minus 2. Less than minus 12. Y by 2 less than minus 12. Okay. So this is much easier. To get rid of the 2 in the denominator, you multiply with 2 on both sides. So we have y less than minus 24. This does not match. This does not match with the question. This does not match with the question. Let's see option D. Let us see option D. We have minus 3y greater than 18. Minus 3y greater than 18. To get rid of the minus 3, you divide this thing by minus 3. So minus 3y divided by minus 3. Okay, you can directly write y is 18 by minus 3. Now the inequality reverses its sign because you are dividing with minus 3. So this comes out as minus 6. So y less than minus 6. Again, this is the same as the one given in the question. So C is the one that is not matching. So our answer has to be C. Our answer has to be C. Okay. So I'll for the next week I'll share one more sheet. Please go through the sheet and try to solve those questions for the next class. The next sheet will take more time. Okay. Next sheet is going to take more time. So please spend sufficient time on that. Okay. We'll catch you in the next class. Okay then. Yeah, bye.